Question 14 says, when some objects move at high speeds, air resistance has a more pronounced effect. A rifle bullet fired downward has an initial velocity of 2,100 feet per second. If we use that model, or use the model that gives air resistance as the square of velocity, then the equation of change for the downward velocity v in feet per second of a rifle bullet is shown below. So that's our function. It says if the terminal velocity for a bullet is 1,600 feet per second, find the drag coefficient r. So first of all, terminal velocity, that just means, or that's another way of saying that dv over dt is equal to 0 because it's not changing, meaning it reaches terminal velocity and the velocity no longer changes. So what I need to do is I need to set my equation equal to 0, but also they tell me that v is equal to 1,600. So I'm going to type in 1,600 in for v, and then I want to solve. So let's first add the r 1,600 squared to the other side. That way I don't have to deal with negatives. And then if I divide both sides by 1,600 squared, then this should get you, let me type it in, we get 1.25 e to the negative 5, which means 0.0000125. So that would be the drag coefficient. So part B says a meteor may enter the Earth's atmosphere at a velocity as high as 90,000 feet per second. The downward velocity v in feet per second of a meteor in Earth's atmosphere is governed by the following equation of change. So they give us dv over dt is equal to 32 minus 2 times 10 to the negative 18 v to the fourth. How fast will the meteor be traveling when it strikes the ground, assuming that it has reached terminal velocity? So I'm going to set this equal to 0, and I'm setting this equal to 0 because they said terminal velocity. Okay, so I'm going to solve for v here. So I want to subtract 32 and then I'm going to divide by negative 2 times 10 to the negative 18. So v to the fourth is equal to negative 32 over negative 2 times 10 to the negative 18. So I'm going to cancel out the negatives. And I want to raise it to the 1/4 power. So v is going to be equal to 32 over 2 times 10 to the negative 18 raised to the 1/4. And if we type that into the calculator, make sure to put a parentheses around the entire thing and a parentheses around the denominator. So we will get 63,246, and this will be feet per second. And that'll be our answer.